Hello and welcome to our virtual lunch and learn today. We'll be talking about how to identify and specify industrial wireless networks for high performance automation applications. My name is Rachel Green and I'm the digital communications specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Brian Alport, Global Business Development Manager with ProSoft Technology. On the comment section, ready to answer your questions, is McNaughton-McKay's system engineer, Justin Wyman. We'll also have a Q&A portion at the end for Brian to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us here. As you come in, let us know where you're tuning in from in the comment section. You can view recordings of previous virtual lunch and learns on our YouTube channel under the virtual lunch and learn playlist, and we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just coming in, welcome to our virtual lunch and learn, how to identify and specify industrial wireless networks. Let us know where you're joining us from. I see Leanne is with us. Welcome, Leanne. We'll be looking for your questions as you have them in the comments while our presenter, ProSoft's Brian Alport, talks to us about the key considerations of identifying and specifying an industrial wireless network. Hi, Justin. We see you out there. Thanks for joining. Our specialist, Justin Wyman, we'll be ready to respond to your questions in the comment section as we go along, and we'll also have a Q&A segment at the end of Brian's presentation. If you'd like to reach out to us afterward, or if you have further questions, you can send us an email at macandmaclive@mc-mc.com. Just be sure to let us know which session you attended. We'll have that email address on the screen for you at the end of the presentation as well. All right, let's go ahead and get started. Brian, I will pass it over to you now.
Great, thank you, Rachel. Hello all, I'm Brian Alport. As Rachel said, I'm responsible for global business development with ProSoft's portfolio of wireless products. We have a really nice and quick presentation here that's focused on how to identify, specify, and to a certain degree, configure an industrial wireless system for high performance automation applications. So we'll look quickly at what ProSoft has to offer in this space, the types of problems or applications we can solve with it, and the key considerations through the specification and deployment phases. And we're going to do all this with a focus on wireless Ethernet and cellular technologies. It sounds like a lot. I assure you it isn't. Our team here at ProSoft specializes in solving complex and critical communications or connectivity challenges while making it as easy for you guys as possible. And I think this will show through these next few slides. So let's jump into it. To help you all understand where we're coming from, I have a quick snapshot here of who we are. Our business is a little over 30 years old. We're based in sunny California, and our focus has always been on industrial communications solutions. We're best known for our industry-leading protocol converter business, but our fastest growing portfolios are actually our industrial wireless Ethernet portfolio and our cellular portfolio, which is really ideal for secure remote connectivity of remote devices or for connectivity of dispersed assets that you cannot reach with traditional radio technology. So that's what we're going to dive into. So if you have any challenges on the communication or connectivity side of your application, whether it's through protocol integration or the connectivity of remote assets, ProSoft's here to help. And we're here to help globally with offices and support teams all over the world. And we're here to help in any of your critical industrial applications that you may have. So right here, you can see we have three different purpose-built, hardened, and industrial focused portfolios. We've got wireless LAN or wireless Ethernet. This is our RLX2 product family, and it's ideal for real-time data transmission for control systems. We'll talk a little bit about this soon. But first, we can also see that we have this wireless remote access and wireless persistent data network offering. So both of these applications leverage our ICX35 cellular modem, where secure remote access is perfect for remotely troubleshooting, remotely servicing, or remotely commissioning equipment. And the persistent data network is ideal for interconnecting multiple remote sites, whether they're in the same county, different counties, different states, or even different countries. So these are the technologies that we're going to dive into here. But let's start here looking at our wireless Ethernet portfolio. Our hardened and purpose-built portfolio for industrial applications looks like this. It's the RLX2 product family. We leverage 802.11n technology for data transmission in the 2.4 and 5 gigahertz bands, which means data rates up to 300 megabits per second. Though most industrial applications really require less than 60 megabits per second because we're really focusing on the precision timing of key automation data with these products. We have enhanced this base technology with specialized algorithms to ensure a reliable link in several different types of applications. Since our focus is in industrial automation, there's often applications with moving machines. Think cranes, gantries, AGVs, mobile robots. And to better enable these applications, we have something called ultra-fast roaming, which creates a reliable link between the client on a mobile robot and across several access points through the application. So we'll look at that a little closer as well. We also offer access point mode, client mode, and repeater mode in all of our radios. So with one part number, you can engineer a point-to-point application, a mesh application, or roaming application. And of course, to ensure reliability, these things are hardened, they're easy to use, they're easy to deploy, they're easy to troubleshoot. All of this is important in these applications. So that's all nice. So still focusing here on wireless LAN, we can see that we have two different types of applications that we really focus on. The first is the traditional stationary application where the access points and the clients are all fixed. So wireless is used to connect to the controllers or pull remote I/O into a PLC, or simply extend a network and enable a mobile worker to connect to their equipment without physically plugging in. Then on the right, we have this mobile application. This is where you may have mobile robots, AGVs, cranes, other pieces of mobile automation that need to maintain connectivity to a main controller somewhere. Our radios are perfect in these applications. We've got a ton of special features like that ultra-fast roaming that we just introduced, which allows our radios to maintain connectivity through the entire path of travel for the robot without dropping packets. And that's thanks to that 10 millisecond or less roam. That 10 millisecond or less roam is about 5 times faster than any other industrial radio on the market, and about 10 times faster than any commercial radio. And this really enables a ton of next generation use cases as more and more of our applications are connected with wireless. So if we take a step back and really focus on the best use case for wireless Ethernet in industrial applications, it's connecting a controller or I/O on the edge of a network to a main controller or to the network core. That means connectivity of a water clarifier or an AGV or anything that you can't run an Ethernet cable to because it's moving, because of where it is, because you don't want to spend money on trenching, running, or maintaining cables. So I've got these two applications in a little bit more detail here. So first, we can look at this application with an AGV. We do on the ProSoft side and on the Mac side, we do a lot of business in the automotive industry connecting AGVs to the manufacturing system. But the requirements here are the same as many other mobile applications that we work on, including cranes or ASR systems, and even roller coasters and amusement parks. And these are all big focuses for us. So wireless connectivity is required for control data and diagnostic data in these applications. And since there's movement, safety and risk reduction is critical. Many times customers in these markets leverage a safety protocol like CIP Safety or ProSafe to improve the safety rating of their system. When safety comes into play, you need a wireless solution that maintains connectivity and is reliable through the entire application. The reason that is important is because when packets are dropped, which sometimes happens in wireless systems, the safety protocol shuts the system down to a safe state. We help prevent those shutdowns caused by nuisance timeouts, thanks to that ultra-fast roaming feature that we described. So in discrete manufacturing applications, there could be tens of mobile robots that require connectivity through the plant. In a logistics environment, there could be hundreds. So these are big applications, but no matter the size of the application, the details of the solution are generally the same. You have a traffic cop, which is the main controller for the network, connected to several access points throughout the application, and you have a compact PLC on board the mobile machine with a client radio. Oftentimes, these radios would leverage MIMO omnidirectional antennas, but in certain environments, it may be more beneficial to use radiating cable with the access points. Radiating cable is a specialty antenna that we offer. It's essentially a long segment of coax, could be 80 meters long. It radiates the signal through a specific area, which is really ideal in environments with risk of significant interference from other networks or environmental obstacles that could distort wireless signals. So in a mobile application like this, looking beyond the performance benefits of an RLX2, it's also important to make sure the wireless solution is tailored to your specific needs. ProSoft has a huge portfolio of antennas and cables to ensure a custom solution, and we work together with Mac to ensure that we have what you need as you work with us on your wireless deployments. Then next, we can look here at an example of a stationary application, a little easier. Here we're looking at a water wastewater application, but this could be any in-plant application that's stationary. In this project, we were tasked with connecting the clarifiers to the main controller. These clarifiers had remote cabinets with several electronics to control the clarifier, and the customer didn't want to invest the time or the money to trench cables back to the main controller. So we were able to come in, offer an IP67 radio in each clarifier, and an IP67 radio as a master connected back to the main controller. After ensuring line of sight, which is important, we were able to leverage MIMO omnidirectional antennas to ensure a reliable connection throughout the plant. So beyond the ease of use during installation, this deployment enabled a mobile worker to connect to this system without plugging into the main controller. We're increasingly seeing this as a use case since wireless enables increased connectivity of automation equipment and also more efficient workflows for the end customer. And that's really becoming popular in general automation applications. So in applications like this, where the wireless is outside, potentially in a public area, you want to ensure that link is secure. So on the security side, we leverage the industry-leading standard WPA2 AES encryption. We have options where we can hide the SSID to prevent a malicious operator from seeing it. And we have the option to digitally attenuate the signal, meaning that we can reduce the amount of Wi-Fi that extends beyond the distance of this application. And we could even enable secure bridging mode, which is a feature we have that means only a ProSoft radio can connect to this network. So we have several options to help ensure a secure implementation. That's important when working on something that might be outside. So when we're thinking about the types of applications we can use industrial wireless in, like this in-plant application, it's important to think about your critical applications where ultra reliability is a requirement. If we look at what this means in the converged plant-wide Ethernet network scheme, ProSoft lives where the Rockwell controller is. The control level in your application where there's Ethernet IP communications, possibly with produce and consume traffic and RPIs. We're focusing here on the connectivity at the device level. That critical I/O data that needs to get pulled into the control system reliably. In mobile applications, this is where CIP safety over wireless is critical. We enable CIP safety over wireless. Not every wireless product can do this. And there really is a big difference in leveraging a purpose-built industrial wireless product from ProSoft versus an enterprise-level wireless product from a commercial vendor. And this is important to keep in mind when we're working in our applications. For example, it's important to understand the value of reliability in your application. You need robust and flexible hardware for your network to ensure uptime and productivity. You need the prioritization and precision timing of automation data in your network, and you need the ability to integrate your networking components into your control system with add-on instructions. On the ProSoft side, we get this. We value being your industrial wireless partner, and we understand the importance of all these things. So I think from here, we have a sense of the types of applications we can solve with industrial wireless Ethernet. So once we've identified the application, we can really get started with the deployment of the overall network. And I have a few steps here that outline some of the key considerations during this phase. So the first step, the first thing we want to do here is understand what the technical requirements are of your application. What type of application is it? Is it stationary? Is it mobile? Considering the anticipated layout, what's the distance between the devices you need connected? And do you have line of sight? If you don't have line of sight, you need to add a repeater in between the client and the access point. If you need to go several miles, it may be more cost efficient to use a cellular solution where you won't need a network of repeaters and you won't need to erect towers with powerful and expensive antennas. And we'll talk about what that cellular solution looks like soon. But for these next few slides, we can assume that we're looking at a wireless Ethernet solution. Then we can look at the data rates or the packet rates that are required. Wireless Ethernet is a half duplex system, which means only one device can communicate at a time, and the radios leverage a protocol to detect the usage in the channel to determine when it's safe to communicate. That essentially means the entire system needs to be engineered so the only data that's being sent wirelessly is that essential data that is required for control, that's required for safety, that's required for diagnostics in your application. That means limiting your broadcast packets and maximizing your unicast communications. In the typical control application, we recommend an overall packet rate of about 5,000 packets per second without aggregation. So with that number in mind, it's important to calculate the packet rates across all of the client devices going through a single access point to ensure the bandwidth of the overall wireless network meet the requirements of your application. In a dense application, it may be required to add an additional access point in that main control network. So we already decided that we're looking here through these steps at a wireless Ethernet application. So from here, we can recommend the 802.11n technology. This is the leading wireless Ethernet technology in industrial applications. And it gives us the greatest flexibility with data rates, the greatest flexibility with choosing what frequency we want to operate in. And we'll talk about this soon in these next steps. So the next step then is to start planning and predicting the deployment. This is where we need to consider the theoretical coverage and the placement of the radios and antennas in the application. Are we using omnidirectional antennas, which are great for blanket coverage, like in that water wastewater application we discussed? Are we using directional antennas, which are great when you need to connect a single point at a defined range and location? Considering the location of the clients and access points, what's the distance between the radios? Antennas have a power specification. It's called their gain. So what gain do you need? It's important to not specify the highest gain antenna you can, because that essentially means that you're propagating your network out beyond the physical perimeter of your application, and that could cause interference with your other networks. This is actually why some people who live in apartment buildings have slow Wi-Fi, even though their diagnostics show that they have a ton of bandwidth and that their signal is strong. The issue is that their neighbor's blasting out their wireless network, and if it's utilizing the same channel as yours, your bandwidth just got cut in half without you knowing. So it's important to manage this in your industrial applications. So on the ProSoft side, we have a huge and diverse portfolio of antennas to ensure a custom solution for your application. And we have a piece of software, ProSoft Wireless Designer, PWD. It's a free network planning tool that we offer. We're going to show you a couple pictures of this. But PWD shows all of our available antennas. We even have that portfolio of specialty antennas, radiant cable, which are really beneficial in those niche applications in difficult environments where communications without interference is critical. So this could be through metal shelves of an automated logistics environment for mobile robots, or alongside a roller coaster in an amusement application. While the benefits of that radiant cable really are great, there are a lot of unique considerations during the design and the deployment of that system. So if you're thinking your application may require radiant cable, please give us a call, give Mac and Mac a call. We'll be happy to help look at the system that you're thinking about deploying. So now that we know which radio technology we're using and which antenna technology we're using and where everything needs to be installed roughly, we can start thinking about the configuration of the radios, starting with which RF channel the system should be on. And we can simplify this by saying you basically have 12 non-overlapping, non-DFS channels to choose from. There's 3 in the 2.4 gigahertz band, and there's 9 in the 5 gigahertz band. So if we're looking at a long distance point-to-point application, we're probably going to leverage the 2.4 band because the lower frequency radiation can propagate further than the higher frequency 5 gigahertz waves. 2.4 can also penetrate things like walls a little bit better than 5 gigahertz. So it's important when choosing a channel to choose one that's free from other networks. That's critical. To do this, you can conduct a site survey. There's several third-party tools that are available, or you can simply use our radio and RLX2 to sniff the spectrum and evaluate a list of channels that are used, what devices are on them, and the signal strength of those systems. That's all built into our product, so it's easy to do. So now that you have defined everything, it's really time to get hardware in hand and deploy the system. This is also a good opportunity to leverage our add-on instructions to integrate your wireless information into your control system. This is a pretty effective way to view and use radio status and diagnostic information in your application. And then finally, you can validate the deployment. You can ensure all physical connections are secure, ensure the wireless connections are engineered. This may be a good time to conduct another site survey to ensure that no additional wireless networks have been deployed in close proximity to your system without you knowing. And we also have a feature that's called, rogue AP detection, rogue access point detection, that you can run that flags anything that's in the same channel as your system. And this could be really useful to run at this stage. So while going through these steps, it's critical to keep a few things in mind. You must have line of sight between the antennas to ensure a reliable and predictable wireless link. You must choose a channel free from other networks to ensure the precision timing of data. It's important to have a strong signal strength. Leveraging the appropriate antennas can help with that signal strength, as does reducing the impacts of anything that could cause unnecessary attenuation, like adding long antenna extension cables that you don't need. It's important not to do that. It's critical in these systems to manage the traffic for use in a wireless system. You want to minimize your broadcast packets. You want to optimize your unicast messaging. You want to ensure there isn't unnecessary traffic going over the air. If it's a CIP safety application, you want to optimize the configuration of your PLC for both safety and uptime. That means choosing an RPI and timeout multiplier that meets your safety calculation goals without it being too frequent for a wireless system. For example, an RPI of 50 milliseconds reduces the risk of nuisance timeouts when compared to an RPI of 20 milliseconds. Excuse me. And lastly, you always have the option to hire a professional like our team at ProSoft. We have a great team of wireless application engineers that specialize in ensuring your application is successful. And we can help with basically anything you need: network design support, site surveys, configuration support, and even troubleshooting support. We also offer this free software that's available and is really valuable through the process of engineering a wireless deployment. This PWD really is the most valuable tool that we have. This is the software that I hinted at earlier, and I think there's a link for it below this video to the PWD webpage where you can download it for free. So with ProSoft Wireless Designer PWD, you can take all of the inputs from the steps that we just went through to design your network layout and ensure a strong connection before ordering parts. And this is something that the team at Mac and Mac can help you with, as well as the team from ProSoft. So this tool lets you choose which radio technology you want to use. We even have our cellular radios in here, so you can use it for more than just a wireless Ethernet system. Then, considering the radio you chose, the tool lets you choose an antenna from our massive portfolio of antennas. We have a list of several different types of categories, several different gain levels, and considering the distance between the antenna and the radio in your application, we have several lengths of extension cables also available in this tool. And this tool ensures that all connectors between the radio, the cables, the antennas are all compatible. So you do this for all of your sites, and this tool gives you the estimated signal strength considering the products you specified, the data rates you need, and the distance between the radios. It's pretty powerful. So if you aren't given a green light for an excellent signal strength, you can go back, you can select a stronger antenna, you can add a repeater between your sites, whatever you need before deploying the system. Then the tool provides you a complete bill of materials for your wireless network, so you know what you need to deploy where. And this is all something that Mac and Mac or ProSoft can help you do based on your application details, or you could download the tool yourself and give it a spin. And the Mac and Mac team and the ProSoft teams would be happy to help verify any designs for you if you do end up designing this yourself. So that was all wireless Ethernet. Let's look here at our cellular or long distance networking solutions. This is where things start to get cool. We actually have two hardware products that fit in this portfolio. One is a cellular gateway, and the other is a networking bridge that simply plugs into a local internet connection. Then we can connect these products to the ProSoft Connect platform, which allows us to offer a secure remote access solution and what we call a persistent data network solution. You can think of secure remote access as simply remoting into a machine or network. It's a VPN tunnel that's created and connected on demand by the user. Then on the persistent data network side, you can think of connecting multiple remote sites as if they are all plugged into a layer 2 switch. leveraging, and this technology leverages a secure VPN tunnel with an always-on connection. So let's look at these technologies in a little more detail. So our remote access solution is as easy and as secure as it gets. The cellular gateways could be AT&T, could be Verizon, could be any carrier globally, and we can commission the SIM cards for you to get you up and running as soon as possible. Unlike a lot of competitors who have similar technologies, we don't require any special software. All you need is an internet connection, and you can access your gateway through ProSoft.io, which is the website. That takes you to ProSoft Connect, and I'll show you how easy that is soon. So ProSoft Connect is our cloud-based networking service that we've built extra security and ease of use into for these applications. Our solution leverages industry-leading tunnel encryption and adds an extra layer of SHA algorithms for security. And we have a few unique features that ensure the end customer has complete control over who remotes in, when they remote in, what they remote into, all digitally. So for example, we have a unique feature that's called Virtual Lockout Tagout, VLOTO. With VLOTO, the end customer can be set as the system administrator for the remote access solution. Then when an OEM or anyone who wants to remote into that system requests to remote in, ProSoft Connect sends an email to the system administrator with the details of who requested access, how long they requested access for, and what they're requesting access to. The administrator can dynamically and digitally accept or decline the request, all from this email. They can also deny the request after accepting the request, kicking them out whenever they want. So the administrators all the power. They have the power to whitelist the IP addresses that the requester has access to ensure that they're only accessing the equipment that they need to get into. Then on the monitoring side, we have a really nice data logging solution that pairs well with this remote access solution. Our solution offers a huge max record count with 50 millisecond intervals for up to 200 tags. The data in this logger can then be exported in a CSV file and supports REST API to collect JSON encoded data. And we have recently partnered with Excel Reporter, so the Excel Reporter system can pull the data from this module. So we see a lot of projects with these types of products, with this solution, with OEMs who need to maintain service contracts with their customers. So as a function of an enhanced service level agreement, they would install a remote access gateway in their machine, and sometimes a data logger, to monitor and provide enhanced support to their customers. And in many cases, this has enabled a new business model with new revenue streams for these OEMs. And this is an interesting increasing trend that we're seeing. So it's definitely something to keep an eye out for all of us to see if we can benefit from remoting into our equipment. Then on the other side, we have our PDN solution. With PDN, we took the ease of use and enhanced security of our remote access solution to create that always-on VPN connection. And this really is the most secure and reliable and future-focused solution on the market for interconnecting multiple remote sites, no matter where they are. So previously, you may have specified an antiquated technology like a 900 megahertz frequency hopping radio for long-distance I/O communication. But that's proven slow and unreliable and really hurts the future flexibility the customer has with their application. To better enable these types of applications, to make them more reliable, we can now leverage ProSoft Connect to connect their sites over cellular or over a local internet connection with that network bridge. Another benefit of this solution is that it doesn't require an expensive VPN server to be purchased and maintained at the customer site. ProSoft Connect takes care of all of this. All you need is a cellular modem or network bridge from ProSoft and ProSoft Connect. So the projects that we're seeing most frequently with PDN are water, wastewater, or oil and gas applications, where the end customer needs to connect multiple remote sites. This technology is also proven valuable for integrators or value-added distributors for these markets who are able to deploy this network and then remote in at the customer's request to provide support in their application. So think about this. The ability to quickly remote into a remote site to service equipment is pretty valuable, especially for a large deployed network like what we typically see in a water wastewater application. And after talking to a few end users in these types of applications, I've learned that they estimate an additional about $150 in unscheduled maintenance per site per year. So that's 15 grand a year in waste for the typical system. And this is important for us to keep in mind. So beyond this ease of use and security benefits, in these types of applications, ease of deployment is important. With ProSoft Connect, you don't need to erect tall and unattractive towers with large antennas. In many applications with utilities, the locality actually won't allow new towers or large antennas to be installed due to the aesthetics. So it's secure, it's reliable, it's easy to deploy, it's easy to maintain. We do it for you through ProSoft Connect, and you don't need to be a networking expert to deploy. These are all important. So just to show you how easy it is to get started, check this out. It all starts with a gateway. Remember, this could be a cellular gateway or a wired network bridge. Then you create an account with ProSoft.io, which is free. Then you create a project for your application or for your customer. Then you give your customer administrative rights for that virtual lockout tagout feature that we talked about, and for IP whitelisting to ensure that they have complete control of their application. And if this is a PDN system, everything's now connected. If this is a remote access system, everything's ready for the on-demand VPN connection. At the request of the customer, the OEM or the service provider is able to securely remote in to the application through hitting this connect button and entering in a one-time unique passcode that the system provides. Then all key metrics, I'll say, of the remote access solution are available on this webpage for future use. Everything from activity logs to cell signal strength to VPN data usage, it's all available. And it really is just easy to get up and running. It takes no time at all. So that being said, how can Mac and ProSoft technology help with your wireless needs?
Thank you, Brian. That was a great presentation. It does not look like we have any live questions in the chat, but right now we'd like to invite you to ask any questions that you have for Brian now. This is our Q&A portion, so if you would like to drop any of your questions there in the comment section, I'll be sure to read those out and Brian can respond. We do have one question that has come in here, Brian. I'll go ahead and read it out for you. With wireless Ethernet, what is the max distance allowed between wireless hotspots?
Yeah, that's a good question. And it's actually, it's valuable to play around with that in ProSoft Wireless Designer. But considering if you have a line of sight on a tower, we've had applications that are in the mile long distance range without repeaters. So it's definitely critical to conduct a site survey to make sure that the signal strength is where it needs to be and you have strong directional antennas.
Okay, great. While we wait to see if we have any follow-up questions, I'd like to reiterate that you could always reach out to us at the email address there on your screen, macandmaclive@mc-mc.com. Just be sure to let us know the title of the session that you attended. We'll be sure to get your question to the right person. And you can always watch recordings of Virtual Lunch and Learns on our YouTube channel. This will be a recording that is also available for you to reference if you want to come back to it later. There's a Virtual Lunch and Learn playlist under our YouTube channel that you can refer to there. We have one more question. This one's from Justin again. With PDN, do I need to have a cell plan for each site or each cell modem?
That's a good question. So just like any cellular device, you would need a cell plan for each device, so each modem. And those cell plans could be provided by ProSoft. We have a relationship with all of the providers, so we have very competitive rates to make sure that we get you a cost-efficient remote access or PDN solution.
Awesome. That is great. Yeah, thank you so much for this wonderful presentation. We'll give just another second here to see if we have any follow-up questions from anyone. But we want to thank you for, sharing all of this technology here on the YouTube channel. It's really a pleasure having you here. And wonderful. Looks like we've slowed down on the comments here in the chat. So we'll go ahead and say goodbye for now. Thank you, Brian, for a wonderful presentation again. Thank you to Justin for being our resource out in the comments section during this presentation. We hope this session was informative and engaging for you. Thank you to all of our viewers here on the channel today. And remember to subscribe to the McNaughton-McKay YouTube channel for more industry content like this. We look forward to seeing you live again soon. Thank you, everyone. Have a great day.